Halleck, and this is my lab 3.
Here is my circuit board with the chip all wired up. So the code begins by entering an infinite while loop where there are two arrays that are being constantly appended, one of them being a time array and one of them being a voltage value array. There's also a slope array as well to compare the previous and current slopes of the current wave. So when it tries to differentiate between square, sine, and triangle, it begins first by testing if the current slope minus the previous slope is greater than the amplitude. If that's true, then we know it's a square wave because it's a very quick change of slopes, which the square wave is. And then from there, it calculates the time for a half of a period. And then next we do the sine wave. So what the sine wave does, for the sine and triangle waves, they're kind of done simultaneously. Essentially, if the slope hasn't changed with a confidence interval of 70%, then it's safe to assume it's a triangle wave. And this works pretty consistently. So then after that, if the confidence interval is too low, it will pick a sine wave instead. And then the same thing applies where it finds the timing it takes to get through half of a period. Then over here, we just have some if statements after the array of values has exceeded a length of 100. And those if statements set the output to square, triangle, or sine, and it sets the frequency output as well. And then in the end of it, it just resets all the variables so that we can go through the next iterations. So to start off my demo, I'll begin by doing a square wave at 5 Hertz. So here you go. And it's not in real time, so it doesn't print anything out until after a second of sampling. And here you can see it's finding a square at 5 Hertz. Now there is a little noise to the timing, so it got 5.49, but it's pretty close to 5. And here we'll change it to 2 Hertz. Just to see a different frequency. And there you go. Frequency is now 2. So now we'll do a sine wave at 2 Hertz. And it should change in any second. There you go. And then next we will do a triangle wave at 2 Hertz. And there we go. It's detecting the triangle wave.